This lesson covers a concept that is from last semester, but we're going to talk specifically about the details for an isosceles and equilateral triangle. Whenever we look at an isosceles triangle, that is a triangle that has two congruent sides. That's what makes it isosceles. That's its definition. And when we talk about an equilateral triangle, we're talking about a triangle that has three congruent sides. So let's first focus on an isosceles triangle. Over here on the left of your paper, you've got an isosceles triangle, and it's got all of its different parts labeled. Notice the two sides that are marked congruent on the left and on the right-hand side, they're labeled as legs. Anytime we talk about the legs of an isosceles triangle, we're talking about its two congruent sides. Notice the third side on the bottom, the base, is the third side that's not the congruent side. The other parts of a isosceles triangle are its angles. Notice the bottom angles down here, the two on the left and the right, are called its base angles. The reason it's called its base angles is because they're along the base of the triangle. Those base angles are always going to be congruent in an isosceles triangle. So not only does an isosceles triangle have two congruent legs, it also has two congruent angles. The third angle up top is not labeled as anything, but you'll often hear it referred to as the vertex angle. So the base angles are the two congruent ones in an isosceles triangle. The legs are the two congruent ones in an isosceles triangle. The base of the triangle is the third side not congruent to the other two, and the vertex angle is the third angle not congruent to the other two. The theorems down here on below, the first one is called base angles theorem. It's what we just talked about above. If we have two congruent sides of an isosceles triangle, that automatically means that the two angles at its base are congruent. In this case, angles B and C. The converse of base angles theorem says the exact opposite. If you've got two congruent base angles in a triangle, that automatically means that the sides opposite are congruent, making it an isosceles triangle. The last theorem has to do with equilateral triangles. We know by definition that an equilateral triangle has three congruent sides, but it also has three congruent angles. Anytime we're talking about a triangle, all of the angles in a triangle add to 180. So if all of the angles are the same, dividing by 3 tells me that in any equilateral triangle, every angle is always 60 degrees. Doesn't matter how small or how large the equilateral triangle is, all of its angles will always be 60 degrees. What we're going to look about for these three problems is, first we need to identify that numbers 3, 4, and 5 are all isosceles triangles. And so we're going to use those theorems and definitions in order to solve the problem. The first thing we're going to talk about is the fact that we've got an isosceles triangle here in number 3, and what we need to do is decide which of the two angles are the base angles, because they are the ones that are congruent. If I have congruent sides on the left and right, that means that the base is this top side, and those two angles I circled are the congruent ones. Meaning that if the angle on the left-hand side is 3x, so is the angle on the right-hand side. So what you notice is you now have the three angles inside of a triangle. So just like last semester, we know that those are going to add to 180 because that's true for any triangle. Adding the x's, we get 10x. And if we divide, we end up with a value of 18. In number 4, again, we have an isosceles triangle, two congruent sides. So we have to determine which two angles are the base angles. They would be along the base, the third side. So the two angles I circled are the congruent ones. Anytime we have congruent angles, all we have to do is take them and set them equal to each other. By solving this very simple equation, we would subtract 7 to get 45. And we would divide by 5 to get an x value of 9. In the last problem over here, number 5 we'll call it, we have two congruent angles marked. So by the converse of base angles theorem, we know we also have two congruent sides, those being the legs of the triangle, the 16 and the y plus 4. So if I know those sides are equal, I can set them equal and just simply subtract 4 to get a y value of 12. Things to keep in mind with triangles. You're never going to add side lengths together and add them to 180 because 180 degrees is for the angles of the triangle, not the side lengths of the triangle. That's a very easy mistake that happens a lot. Down here in these three problems, notice that you're told that they're equilateral triangles. So we know all three sides are the same. That also tells us that all three angles are the same. So in number one, all three of these sides are the exact same, which means that all I have to do is take two of them and set them equal to each other. It's a very easy equation to solve. So if I subtract 2x from both sides, we get x equals 10. In number two, you're told again all three sides are the same. Now notice that they've given you all three sides of the triangle. You actually don't need all three sides in order to solve for y. You only need two of the three sides. It really doesn't matter which two you pick. So if I were to pick the top side and the left side, 2y equals 10 is going to give me a y value of 5. Say I had chosen to pick the top side and the right side. Y plus 5 equals 2y. Subtracting y again gives me y equals 5. Say I had chosen the right side and the left side. If I set that y plus 5 equals 10, I again get y equals 5. So notice that no matter which two sides you pick, the value of y comes out the exact same in every single case. In number three, it's a problem just like number one. If I have three congruent angles, I know I have three congruent sides. And all I have to do is take those sides and set them equal to each other. Solving this equation is going to require a few more steps. So I'm going to subtract 4y from both sides. I'm also going to add 10 to both sides, giving me an equation of 4y equals 12. And if I divide by 4, we get a y value of 3. Flipping to the back, a little bit more complex of a picture. Not as algebra intensive on these pictures, but it does require a little bit more thought process. So let's look and see what we're given here. In this triangle on the right-hand side, we should all notice that it is an isosceles triangle, meaning that there are two angles that are the exact same. Those angles being the one labeled as x and the one not labeled with anything. So I'm again going to label it with the same thing, which is x. Solving for x becomes easy because it's a triangle. I can add the x's together and the 50. And if I set that equal to 180, I can solve for x because I know all the angles in a triangle add to 180. Solving the problem, I'm going to subtract 50. And then I'm going to divide by 2 to get an answer of 65 degrees. So that's your value of x in this particular case, 65 degrees. Now, why is that important? Why did I have to find that before I find y? The reason why is because this angle here and this angle here form a linear pair. Remember from last semester, linear pairs are angles that form a line when put back to back. And more importantly, they make 180 degrees because they form a line. So if I want to figure out this vertex angle here, all I have to do is subtract the 65 from 180, and we get a value of 115. Now, why that's important is because, again, you have an isosceles triangle here. The two congruent angles are the one labeled as y and the one not labeled with anything. So again, I'm going to relabel that with a y, and I'm going to use the same process we used in the bottom. If I add the y's together and the 115, we should get a value of 180 because we're adding the angles in a triangle. So subtracting the 115 is going to give me 65. And then dividing by 2 is going to give me 32.5. Remember, not everything in life comes out nice, neat whole numbers, so it's okay to get a decimal. Probably not going to get a messy decimal, something like a 0.5 or a 0.25. Those are not messy decimals. In the next problem, notice we've got three triangles now here to look at. The one on the very right-hand side is an equilateral triangle, which means that all of these angles are 60 degrees. That's going to be important. Okay, so here's why that's important. If I look at these three angles together, they form a line together, which means that they have to be 180 when you add them all together. The one on the left side is 40. The one on the right side is 60. So if I want to figure out what's left over, there's 80 left over for this middle angle. So why that's important is because this is an isosceles triangle, which means I have two congruent angles, one of them being the 80 I just identified, and one of them being this blank one up here, which would also then be 80. So to figure out x, we use the fact that all the angles in this triangle have to add to 180. So if I take 180 and I subtract off the 80s that I just had, we end up with an x value of 20 degrees. The last thing we need to find then is y. Again, I have an isosceles triangle, which means I have two congruent angles, bottom right, bottom left. Bottom right angle is 40 degrees, so is the bottom right angle. So if you want to figure out what y is, again, using the fact that the angles in a triangle add to 180, subtract off the angles that you know, and y has to be a total of 100. Coming down, we get to some more pictures that have x's and y's in them. So let's just go through them one by one. In number one, first thing is this is an isosceles triangle. So you want to identify which angles are the congruent ones. They would be the top two because they're along the base of the triangle. So that means that I can take those two angles and just simply set them equal to each other. And the solving for that is pretty easy. You want to add 11 to both sides. You want to subtract 2x from both sides. That gives you an x value of 22. Now, in order to figure out y, what you have to do is take the 22 and you have to plug it in. So if I plug in 22 for x, since it represents x, 2 times 22 and add 11 would give us a value of 55. Meaning that this angle on the left-hand side is also 55. So together, that's 110, meaning that this angle here, there's 70 left over for that angle. So if I want to figure out what y is, I take 2y, set it equal to 70, and if I divide by 2, we get a y value of 35. Once I have solved for both of those, that's all the problem asked for, so we move on. Again, in the next problem, we have an isosceles triangle, which makes two congruent base angles. So if the one on the left is x minus 2, so is the one on the right. So when I add the angles together, since it's an since it's a triangle, I want to add them so that they make 180. And now it's just about combining like terms and solving the equation. So I've got 6x's plus 6 equals 180. If we subtract 6 from both sides, we end up with 174. And then the last thing I would do is divide by 6, which should give us an x value of 29. So what you want to do now is you want to figure out what the value of y is. In order to do that, you have to plug the 29 in. So 29 minus 2 gives me a value of 27 degrees. For this angle, that angle right there is 27 degrees. Now, it's important because if you look at this angle on the outside and the angle on the inside, they form, again, a linear pair. What we should remember from last semester is a linear pair is two angles that add to 180 because they form a straight line when put back to back. So if I take 3y and 27. I should be able to set them equal to 180 because, again, it's a linear pair, and a linear pair always adds to 180. So to solve the equation, you would subtract 27 to get 153. And then if I divide by 3, we should end up with a value of 51. So there are your values of x and y. In the next problem, again, I've got a couple of triangles. This time they're both isosceles. So let's figure out this one here first. The reason why I want to start there is because I've got 2 of the angles labeled. In the other triangle, I only have 1 of the angles labeled. So I've got an isosceles triangle, which means I have congruent base angles, which are the 2 that are labeled. So all I need to do is simply set them equal to each other. Solving is going to require a couple steps. First, I'm going to subtract 3x, and I'm also going to add 10 at the same time. We get 20 equals 2x. And if we divide, we get an x value of 10. In order to figure out y, we're going to have to plug in the 10. So we get 3 times 10, add 10. That's going to give me an angle measure of 40, which is the same as this one up here. That's important because if those 2 are 40, that makes this angle up here 100, because they all have to add to 180. 40, 40, and 100 gives me 180. Then I want to look at the fact that this little triangle over here on the right side, the left side, is also isosceles, meaning that I've got 2 congruent angles, those being 4y and the blank one. So this blank one can also be labeled as 4y because we just said they have to be the same. So if you look at the angle here labeled as 4y and the angle here labeled as 100, those 2 angles form again a linear pair, which means that they have to add up to be 180. So that 4y on the left, the 100 on the right, have to add to give me 180. And so it's just a simple equation to solve once it's set up correctly. Subtract 100 to get 80. Divide by 4 to get a y value of 20. Moving down, we've got some ACT type problems. Now keep in mind when you're working out an ACT type problem that the ACT tries to trick you. They work the problem out in several different wrong ways, and they do put those as answers so that if you work it out a wrong way, one of the answers that you get may match what one of theirs says. So make sure you're paying attention to what you're doing so that you're not working the problem out incorrectly. For example, this problem looks like it would be equilateral because the side lengths all look the same. However, they're not. I've got 2 congruent angles, which means that I have 2 congruent legs because it's an isosceles triangle. Those legs are the ones across from the angles, which are the ones I just labeled with tick marks. So all we're going to do is set those legs equal and solve for x. Something that you don't want to do, don't add the 3 sides together and say that they're equal to 180, because side lengths aren't equal to 180. Angles are equal to 180, not side lengths. So to solve this problem, now that it's written correctly, we're going to do a couple steps. Going to subtract 1 and subtract x. So we get 10 equals 2x. Divide by 2, and we get an x value of 5. So we have an answer of letter B. In number 2, this triangle is a right triangle. So some things to notice. I've got a 45 degree on the top, a 90 on the bottom left, which means that this angle here has to be 45 because all the angles have to add to be 180, which means that this is an isosceles triangle. 2 congruent base angles make 2 congruent side lengths, those being the ones I just put tick marks on. So we know that they are just going to be set equal to each other, and we're just going to solve for x. So things to notice in the last 2 problems. The bases of these triangles were just extra information that you actually did not need. You only needed the legs. So some steps, subtract 3x and add 8. So 12 equals 4x, and I get an x value of 3. Now notice that that's one of the answers, but it actually doesn't answer the question. The question says, what is the length of a leg? So you actually have to take the 3 and plug it in to figure out the answer for the question. 3 times 3 is 9. Add 4, you get a value of 13. So again, an ACT type problem. If you're not paying attention to what the problem is asking, you may have incorrectly selected letter A, even though you did the problem correctly. So make sure you're reading so that you know what the problem is asking you for. 2 more problems, and they're both related. The first one asks you for x and y in this picture, and then the second one asks you for w and z in the same picture. So we're going to use the same diagram for both problems. So some things to notice. We've got an isosceles triangle, which means 2 congruent angles. So this angle here is 35. So if I want to figure out what y is, subtract the 35 and the 35 from 180, and you get 110 for y. Notice that y and x form a linear pair, which means that y and x have to add up to be 180. So that means that x has to be 70. So x is 70, y is 110, your letter C. For number 8, it asks you to find w and z. W and this 35 over here form a linear pair. So w plus 35 has to make 180. And if I subtract 35, we end up with 145. If I want to find z, we should notice that I've got this angle here as 70. This angle here, that I have a right angle at the bottom left. If I know that the very bottom portion is 35, I can subtract that from 90 to get 55 for that extra part. And what I have here is a triangle where all the angles should add up to be 180. So z plus 70 plus 55 should equal 180. Adding the 70 and 55 together gives me 125. And if I subtract from 180, I get a value of 55. So W 145 and Z 55 would give me letter D as my final answer. If you have any questions over the explanation for any of the problems, make sure that you make note of that, so that when I ask for questions next class, you are able to say, Mr. E, number 8 didn't make any sense to me. Can you please re-explain how you found W and Z, because I just didn't follow your explanation. So specific questions help me give you specific answers, and hopefully will clear up your understanding. So please let me know if you have any questions.